Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. We are starting with the concept of stationary points. Now, stationary points is a subtopic of differentiation of P1, and differentiation is one of those chapters that we study in P3 also. Now, this terminology of stationary point, uh, we have used a similar name that is called turning point. We have used another name that is called vertex. And these are the three chapters where this terminology was used. That is quadratics, that is functions, that is trigonometry. And now we are using this thing in differentiation. Now, first of all, let me write down an equation in the completed square form. Y is equals to x minus 1 whole square plus 4. And let me compare it with the gold standard, the completed square form, ax minus h whole square plus k. Now let me write a 1 over here because no constant is written on the outside. So now if I compare coefficient and this thing over here, this 1 is the same as a, this 1 is the same thing as h, and this 4 is the same thing as k. So let me write it down. So therefore, a is 1, and h is 1, and k is 4. That means 1, 4, that is the coordinate of the turning point. And since a is positive, that means the shape of the graph is like this. In other words, 1, 4 is the coordinate of the turning point. This turning point is a minimum. This is the knowledge that we have gained from quadratics. And I think everyone is aware of this. Now, if I draw a graph over here, the y-axis, the x-axis, the curve that's going like this, and let me just shift this thing a little bit on this side. And the curve is going like this. So now over here, this is 1, and this is 4. That is the x coordinate of the turning point. And from the shape, we see that 1, 4, this is a minimum. Now, what if this knowledge was not given? Is there any other way of doing it? Yes, there is. So now when we have to calculate coordinates of stationary points, there are a few things that we need to consider. So first of all, the thing is that dy by dx, we will calculate, we will equate it to 0. We will get x coordinates of stationary points. The second thing that we will use is that to find y coordinates of stationary point, y coordinate, yeah, coordinates of stationary points, ST points, what do? Plug in x coordinate of stationary points in equation of curve, and you will obtain it. Very simple. Third one, that is to find nature of stationary points. What do? We plug yx coordinate of stationary point in second derivative. What do we mean by second derivative? That means derivative of derivative. Second derivative means derivative of derivative. And of course, I'll do some examples. Derivative of derivative. And there are three possible options. The first option, if the second derivative, that is how we write it, d square y over dx square. If this second derivative is positive, it's a minimum point. If this derivative is negative, it's a maximum point. And if this derivative is 0, we would say it's neither max nor min. neither maximum nor minimum. And we will also do an example which would illustrate this fact. So now, why don't you take a screenshot of this? Of course, you will be copying it later. First, take a screenshot because that is exactly what we are doing. Okay. So now let me apply the same knowledge. That is x minus 1 whole square plus 4. So let me write it over here. So y equals to x minus 1 whole square plus 4. dy by dx, that is the first derivative. 2 comes down, x minus 1 remains as it is, power reduces by 1, derivative of the bracket is 1, and derivative is 4 of 4 is 0. So this is the first derivative. And this is obtained using chain rule. Power comes down, bracket remains as it is, power reduces by 1. Don't forget to multiply by derivative of bracket, which is 1. And derivative of this constant is 0. And let me also write chain rule over here. Y is equals to something in bracket raised to power of n. Therefore, dy by dx, n comes down, bracket remains as it is, power reduces by 1. And don't forget to multiply by derivative of bracket. And we know that derivative of a constant is 0. So now this is the first derivative. I can even write this thing as 2x minus 2. Second derivative, d square y over dx square, that is how we write it. This is called derivative of derivative, which is second derivative. Over here, the derivative of 2x is 2, the derivative of 2 is 0. So this one over here, this derivative of 2 is 0. Derivative of 2x is 2. So this is a positive value. So this is 2. Now let's apply all the 3 steps. First one, dy by dx equals to 0. We find x coordinate of stationary point. So we will write it like this, x coordinate of stationary point. To find y coordinate of stationary point, plug the x coordinate in equation of curve. To find nature, plug x coordinate in second derivative. If it's positive, it's a minimum. It's opposite kind of thing. If it's negative, it's a maximum. If it's 0, it's neither a max nor a min. Now, first of all, step 1. dy by dx equals to 0. What is dy by dx? 2 bracket x minus 1. So 2 bracket x minus 1 equals to 0. Get rid of 2. X minus 1 equals to 0. Therefore, x is 1. Therefore, x coordinate of stationary point is 1. We will check the answer at the very end. Second step, to find y coordinate of stationary point, plug x coordinate of stationary point in equation of curve. What is the equation of curve? X minus 1 whole square plus 4. When x is 1, y is 1 minus 1 whole square plus 4, which is 0 square plus 4, which comes out to be 4. Therefore, 1 comma 4, that is the coordinate of the stationary point. Step number 3. To find nature, use the second derivative. X coordinate of stationary point will go in second derivative. But there is no need over here because the second derivative is already positive. So without plugging, because there is no plugging in, the second derivative d square y over dx square is positive. Therefore, the conclusion is minimum. We don't need the value. We just need the sign. In other words, the final answer over here is 1 comma 4. That is a minimum point. And that is exactly what we have obtained over here. That is 1 comma 4. Yes, it's a turning point. It's a stationary point. and this turning point, this stationary point is a minimum. All good, all clear. So just acknowledge something. So of course, I have to write that something so that the basic concept. So stationary point, let me write it down. Stationary point, 3-step, what you call a procedure or process. All good, all clear. So just put a tick mark over there, and I'll know for sure that you have understood it thoroughly. So this is the first group, this is the second group, and then there is the third group. Okay, I'm waiting for your acknowledgement. Now, someone asked this thing, why are we plugging in the second derivative? P1 and P3 is not the right level to make you understand that. For right now, that is the procedure that we need to follow. So we just need to follow and nothing more. I'm making a question for you people. Now, first thing that I'm writing over here is that find coordinate of stationary point or points and determine its nature. This is y is equals to x cubed. So take 2 minutes, try out and give me the answer. I'll just pause the recording for a short while. Now, look at this particular question. What is so special about this question? Working wise, it's very simple. First of all, dy by dx equals to 3x squared, and d square y over dx squared, that is 6x. Now, the first step is that dy by dx equals to 0, dy by dx equals to 0, 3x squared equals to 0, x squared equals to 0, therefore x is 0. Second step, that is when x is 0, y is x cube, y is 0 cube, which is 0. Therefore, we are talking about the origin. The third step, that is the nature, the second derivative test. That is how it is referred. The second derivative test. Now, x is equals to 0 is plugged in the second derivative. So d square y over dx square is 6 into 0, which is 0. Therefore, it's neither a maximum nor a minimum. Yes, it's a turning point. Of course, there is a turning point, but the nature is neither a max nor a min. Now, how is this thing possible that it's neither a max nor a min? So we have to show it using a graph. So let me just draw the x-axis. And let me draw the y-axis. This is simple x cube. And let me just draw the graph like this. So this is one half of the graph, and this is the other half. Now, when we talk about y is equals to x cube, that is the turning point. And if this was a minimum point, it would have risen up. If this was a maximum point, it would have gone down. So yes, it's a turning point, but neither max nor min. It's just a turning point. So I hope the simple example is making all things clear. Now, that is the basic concept. We can get started. Why is the page different? Okay, so we can get started with this thing. So now let's look at the question. Now, the question is all about this thing. The equation of a curve, this is a past paper question. The equation of a curve is this. obtain expression for dy by dx, d square y over dx square, the second derivative. Find the coordinates of the stationary point. That means the x coordinate, that means the y coordinate, and determine its nature. So why don't you go ahead and try this out? Let me pause the recording. So now let's look at the solution of this particular question. The very first thing that you need to do is that write it properly. Y equals to 2x plus 8x minus 2. That is the first thing. Y equals to 2x plus 8x minus 2. That is the original thing. Dy by dx, that is the first derivative. 2x becomes 2, 8 as it is, negative 2 comes down, x remains as it is, power reduces to negative 3. And then d square y over dx square, 2 becomes 0, 8 into negative 2 is negative 16, negative 3 comes down, x negative 4. Now, for the purpose of differentiation, we need this format in which the variable is on the top. So negative index, positive index, negative index, or power, that is what is needed in order to carry out differentiation. But for the rest of the working, we need this. So dy by dx is 2 minus 16 over x cubed. And d square y over dx square, that is negative 16, negative 3, that is positive 48 over x4. So this particular format is needed for maybe working it out, solving. That is basically working it out and the proper way to write it. So working wise for differentiation, the red format is needed. For further working, the purple format is needed. Now, when we are talking about the marks, so basically you will get 3 marks for these two. So basically, maybe 1 mark for this and maybe 2 marks for this, or vice versa. Now, the coordinates of the stationary point. So let me take it to the next page. And over here, we have dy by dx. Let's make it equal to 0. So dy by dx, that is equal to 2 minus 16 over x cubed. This is 2 minus 16 over x cubed. So dy by dx equals to 0, first step. So negative 16 over x cubed is equals to negative 2, negative cancel. X cubed is equals to 16 over 2, which is 8. Therefore, x is cube root of 8, which comes out to be 2. Positive value will give a positive cube root. Negative value will give a negative cube root. The second step, that is this thing, which is when x is 2, y is equals to, what is the original equation? 2x plus 8 over x squared. This is 2x plus 8 over x squared. This is 2 into 2 plus 8 over 2 squared. This is 4 plus 8 over 4 is 2. This comes out to be 6. Therefore, the coordinates are 2, 6. Now, let's determine the nature. For nature, we need the second derivative, which is 48 over x4. So d square y over dx square is 48 over x power 4. When x is 2, d square y over dx square is 48 over 2 power 4. No need of using the calculator because this is positive. This is positive. The overall sign is positive. Therefore, this is a minimum. So now let's check the answer. X is 2, y is 6. It's a minimum because the second derivative is positive. How many marks for this? 3 marks. So basically 1 mark for each step, 1 mark for the x coordinate, 1 mark for the y coordinate, 1 mark for this thing, and then you get 3 marks out of this. So I hope this is all clear. Now I have taken this extra initiative of showing you the graph of this 2x plus 8 over x squared. Of course, they're not asking us to draw the graph. I'm just showing you that there is one turning point. This is 2. This is 6. And you see it that this is a graph of a minimum. So that is what I've done over here. The second question, let me do this thing. So y is equals to this thing. So let me write y is equals to 9, 2 minus x raised to power of -1. Find an expression, determine with the reason whether the curve has any stationary points. So dy by dx, according to chain rule, 9 remains as it is, -1 comes down, 2 minus x, power reduces by 1, and the derivative of the bracket is -1. Look at all the steps. Power comes down. Bracket remains as it is. Power reduces by 1. Don't forget to multiply by derivative of brackets. So derivative of -x is -1. So now this is negative, this is negative, that is positive, this is 9. So this is 9, and write it as 2 minus x raised to power of 2. This is dy by dx. Now when I equate dy by dx equals to 0, 9 over 2 minus x whole square equals to 0. What happens? 9 is equals to 2 minus x whole square into 0, which gives me 0. What is this? The variable disappears. We cannot make x the subject. Therefore, x can't be found. And when x can't be found, that means there is no stationary point. That is the logic. So let me grab my phone, and this particular question, which is very, very important, that concept is this thing, that the variable disappears. So variable disappears. That means variable disappearance, no solution of equation. So in this context, there is no stationary point. There is no stationary point. So all good, all clear. Just acknowledge this thing. This is ES2, this is ES1. Okay. So that is the concept over here. No turning points. And that's how the graph looks, because we have done this graph reciprocal function. That's the graph. There is no turning point. Now, this one, I would like you people to try it out. That is question number 12. Try out question number 12, and let me just share this particular page with you so that I can just readjust the orientation of this particular document, and just check your WhatsApp. Let me just pause the recording first. Now, this time it's a cubic equation, and there are certain other things that I'll explain from this particular graph. It's written as a function fx. So that is x cubed minus 2x squared plus x, f prime x. So dy by dx can also be written as y prime. D squared y over dx squared can also be written as y double prime. F prime x, that means the first derivative in terms of function. And then the second derivative that I'll write, and that is f double prime x. So if I first differentiate, this is 3x squared minus 4x. If I differentiate it again, that is 6x minus 4. So whenever you have this thing, 99% of the time, you have to go to the second derivative. Now, step number 1, f prime x equals to 0. 3x squared minus 4x equals to 0. That is x common. 3x minus 4 equals to 0. Therefore, x is 0. Therefore, x is 4 over 3. There are two turning points. Second step, to find y coordinates of stationary point when x is 0. This is, I forgot the 1 over here, my bad. So the derivative of x is 1, and over here it is 0. So let me just correct myself over here, small mistake that I did. F prime x is 3x squared minus 4x plus 1 equals to 0. Middle term factorization. 3x squared minus 3x minus x plus 1 equals to 0. 3x x minus 1 minus 1 x minus 1 equals to 0. X minus 1, 3x minus 1 equals to 0. Let me erase this thing. Therefore, x minus 1 equals to 0, x is 1, 3x minus 1 equals to 0, x is 1/3. That's the first thing. Second step, when x is 1, f of 1, we need to evaluate the y value. X cubed minus 2x squared plus x. 1 cube minus 2 into 1 square plus 1. That is 1, that is 2, that is 1. This comes out to be 0. Therefore, 1, 0, that's the coordinate of the turning point. When x is 1/3, f of 1/3, that is 1/3 cube minus 2 into 1/3 square plus 1 plus 1/3. Because fx is x cube minus 2x squared plus x, all good. This is 1 over 9. This is minus 2 over 9. This is 1 over 3, which can be written as 3 over 9. So I have written 1 over 3 as 3 over 9. So therefore, 1 plus 3, that is 4. 4 minus 2 is 2. So therefore, this comes out to be 2 over 9. If I'm not mistaken, that is 27. My bad. Another small error because I'm cubing it, not squaring it. So therefore, this one is 1 over 3 cubed, which is 27. This is 2 over 9. This is 1 over 3. So maybe 1 or 2 steps that is needed. This is 1 over 27. 9 into 3. That is 27. 2 into 3, which is 6. 3 into 3, 3 into 9, 27. And this is 9. Now let's do the working. 9 plus 6. Let me use a red marker. 9 plus 1 is 10. 10 minus 6 is 4. So this is 4 over 27. Therefore, the other point is 1/3, 4 over 27. That is the other turning point. Let's double check. X is 1/3 or 1. Y is 4 over 27 or 0. So basically, this is 1, 0. That's one thing. And this is 1/3, 4 over 27. That is the other thing. So this is all good. This is all good. Now let's talk about the nature. So let me add a page over here. And step number 3, that is about nature. So f double prime x, what is that? That is 6x minus 4. This is 6x minus 4. When x is 1, f double prime of 1, that is 6 into 1 minus 4. That is 6 minus 4, which is 2. This is positive. Therefore, this is a minimum. That means 1, 0 is a minimum point. When x is 1/3, f double prime of 1/3, that is 6 into 1/3 minus 4. This is 2 minus 4, which is negative 2. This is negative. Therefore, it's a maximum. So 1/3 comma 4 over 27, this is a maximum. So let me highlight this. This minimum point, this is the minimum point, and this is the maximum point right over here. Now, based upon my knowledge of cubic equation, so we know that, let me just draw this thing. So we know the basics that if I draw a cubic equation and whatever we have studied so far, if the graph of a cubic equation, let me just draw this thing. It could be like this, or it could be like this. If the coefficient of x cube, if coefficient of x cube is positive, it starts from top right and goes till bottom left. If the coefficient of x cube is negative, it starts from top left and goes till bottom right. Now, I'm interested in sketching this graph based upon the coefficient of x cube, that is one thing, and based upon the stationary points. Now, there are two stationary points. So let me draw the x-axis. Let me draw the y-axis. The first stationary point is 1, 0. So there is one stationary point, which is this, which is 1, 0. This one is 1, 0. And the other stationary point is this, which is 1/3, 4 over 27. And the other one is 1/3, 4 over 27, very close by. So the other one is 1/3, 4 over 27. So now the shape has to be the green shape. It's going to start from the top right because the coefficient of x cube is positive. So it's going to start from here. It's going to go down there and also pass through these points. So that is how the graph will be drawn. This is just some extra information. So like this, not exactly like this, a little bit. And something like this. And approximately something like this. So there is this turning point that you see. This is a max. This is a min. The blue one is a max. 1/3, 4 over 27. And the red one, 1, 0, it's a min. So that is how this graph is drawn. All good, all clear? So now let me just show you this graph that I've drawn on the grid using this thing. So that is how these things are. So this is the blue one. This is 1/3, 4 over 27. So let me write over here in blue color. This is a maximum point. This is 1/3, 4 over 27. And this red one, that is the minimum point. That is 1, 0. And this is the blue one that's right over here. And it's starting from top right. It's going till bottom left. And that's how the curve is drawn. All good, all clear? Now, one other thing. So now this cubic sketch, just acknowledge it on the WhatsApp. So a bit idea about cubic sketch. Now, some of you have shown their working. So cubic sketch, is this all good, all clear? It's AS2, this is AS1. I'll just sit back and first go through this. Okay. Now there is something else that I'll do to this graph. And that concept will be used a bit later. I won't reveal to you what is the concept all about, because that element of anticipation should be there. So let me draw this graph over here. And let me draw the grid. That is the x-axis, that is the y-axis, should be drawn a bit. And let me draw it like this. In general, I can draw it. So let me draw 3 portions. No, I think I have to draw it without this thing. That would be better. Okay, now this is better. Let me change the color. Let me make it black. Now, first of all, let me mark a point over here. This is a maximum point. It's not necessary that graph. This is a maximum point. This one is a minimum point. And let me label some coordinates. So let me label this thing as A. Don't worry about the positive negative sign. And let me label this thing as B. Now, this is a cubic sketch. If I draw a tangent over here, so I have drawn a tangent in green color over here. This tangent has a positive slope. If I draw a tangent in pinkish color, this one has a negative slope. If I draw a tangent over here, this again has a positive slope. So there are 3 prominent regions of the graph. We are talking about a cubic sketch, and there are 2 turning points or stationary point, and there are 2 regions. There is some region with positive slope. There is some region with negative slope. The positive slope is denoted by the green color. The negative slope is denoted by the pink color. All good? All clear? Now, if I ask you the range of values of x for which slope is positive. Slope is positive versus slope is negative. So when I talk about slope is positive, wherever I draw a tangent over here till the turning point, because at the turning point, the gradient is 0. That is why we have dy by dx equals to 0. If I have not mentioned this earlier, let me mention it now. When we say dy by dx is 0, because dy by dx is gradient of tangent to the curve is 0. I mean, we are so much involved with dy by dx that we forget to mention this. Gradient of tangent to the curve is 0. That means tangent is parallel to x-axis at turning point. So at turning point, if I draw a tangent over here, Let me draw a purple tangent over here that is parallel to x-axis. This is parallel to x-axis. So that is over here like this. But elsewhere, the gradient, the tangents could have a positive slope or the tangents could have a negative slope. Between A and B, the tangent has a negative slope. So between A and B, the tangent has a negative slope. And what about the positive slope? If I go to the right of B, the tangent is positive. If I go to the left of A, the tangent has a positive slope all along this region, all along this region. So therefore, X is greater than B, X is lesser than A, the tangent has a negative slope. So is this all good, all clear? There's something about positive, negative slope. So let me write it. I'm grabbing my phone. So now we are talking about positive, negative, slope, tangent, dy by dx, dy by dx. That is how I'm writing it. So is this all good, all clear? AS1, AS2, and this thing. Okay. So that is the idea over here. Again, we can have a look over here. Over here, if I am interested in positive slope, that is to the left of this x coordinate. So x is lesser than 1/3. That is to the right of this x coordinate. That is x is greater than 1. This is positive slope. If I talk about negative slope, then that is this portion of the graph that's right over here between these two turning points. So x lies between the two turning points, 1/3 and 1. Okay, so this is all good, all clear. Let me check the WhatsApp. Yes, those people who are over here, it's all good, all clear. Now, a different kind of a question. Question number 11, there is part A, there is part B. Now, let me share these images so that you can try it out first. Let me pause the recording. Recording is resumed. So now let's look at this question. It is given that the curve has equations such and such where k is a constant. First part, find in terms of k the values of x at which there is a stationary point. So now, first thing first, part A, fx or y equals to k bracket 3x minus k raised to power of -1 plus 3x. dy by dx, k remains as it is, -1 comes down, 3x minus k, power reduces by 1, derivative of a bracket is 3. Derivative of 3x is 3. So let me highlight few things. This power comes down, power reduces, derivative of the bracket is 3. So 3x, the derivative is 3. So this goes like this. Okay. And the derivative of this 3x, that is this 3. Now let's simplify it a bit further. So 3k minus 1, that is minus 3k. And this is 3x minus k raised to power of -2 plus 3. That can also be written as minus 3k over 3x minus k, the whole thing square, plus 3. This is dy by dx, that is in terms of k for 4 marks. Let's double check. So that is this thing. We need to, not the expression, we need to find the coordinates of stationary point. So now equate dy by by dx to 0. So therefore, minus 3k over 3x minus k whole square plus 3 equals to 0. Be very, very careful. Minus 3k over 3x minus k, the whole thing square is equals to negative 3. First, get rid of the negative sign. Then get rid of this 3. And now we are left with a 1 and cross multiply. This k remains as it is. This thing will multiply with this. So therefore, k is equals to 3x minus k, the whole thing square. Take square root. Square root of k is 3x minus k with a plus and a negative sign. Read the question again. The values of x, this is plural. So that means there is more than one value of x, the stationary point. Therefore, 3x minus k equals to plus square root of k. 3x minus k equals to negative square root of k. 3x is equals to k plus square root of k. 3x equals to minus root k plus k, and therefore make x the subject. That's 1/3 of k plus root k. And let me write it in that same order. This is k minus root k, and x is equals to 1/3 k minus root k. And everything, all this thing is for 4 marks. So let me just look at this. So they have written it collectively. I prefer to write it separately. K plus root k over 3 and k minus root k over 3. So this is all good, all clear. So 4 marks for this particular working. How many of you got this right? Let me know in the individual WhatsApp. Now it says the function fx has a stationary point. So now the function fx has a stationary value at x is equals to a, and it's defined by such and such. Now, there is some other concept of function also, which we haven't done. So that therefore, I'm not touching that. Just focus on this. Fx is equals to this. Find the value. Find the value of a and determine the nature of the stationary value. So isn't this the same thing? This is k. Look over here. This is k, 3x minus k raised to power of negative 1 plus 3x. So this is k, this is k. So now that k is replaced by 4 and 4. I think they just plugged in the value. So now let's write it again. Fx, that is equals to 4, 3x minus 4 raised to power of negative 1 plus 3x. What I can do is that I can start this value. That is this thing, minus 3k over 3x minus k whole square plus 3. So let me just copy this and let me replace the k with 4. So now let me plug it in over here. That is dy by dx or f prime x. So let me write over here f prime x. That is better. And let me also write over here f prime x because it was not y. So this is f prime x. And let me also erase this thing over here. That is f prime x. So if I compare with original part A, compare with part A, so k is basically replaced by a 4. So now let me erase this k over here. Let me erase this k over here. This is replaced by 4. This is replaced by 4. Rest of the thing is the same. We also have to evaluate this thing further. So therefore, f prime x, let me write it first. That is negative 12. And this is 3x minus 4 raised to power of negative 2 plus 3. Now let me evaluate f double prime x. F double prime x, that is negative 12, negative 2, 3x minus 4, power reduces by 1. Derivative of bracket is this, and derivative of this 3 is this 0. So therefore, this is positive 24. Actually, 24 into 3, that is 72. So positive 72 over 3x minus 4 raised to power of 3, that is f double prime x. Also, we have the coordinates of the stationary point. So this is one stationary point. This is the other stationary point. So we know that x coordinate of stationary point, there are two of them. The first one, x is 1/3 something, and the other one, x is 1/3 something. What is that something? That is k plus root k, k minus root k. So this is k plus root k, k minus root k. This is 4 plus root 4, 4 minus root 4. So therefore, the first one is 1/3. 4 plus 2 is 6. 6 divided by 3, that comes out to be 2. And this is 4 minus 2 is 2. That's 1/3 of 2. That comes out to be 2/3. So we are looking for find the value of A. So has a stationary value, x is greater than or equal to 3 over 2. So therefore, reject this one. This is rejected. And this one is accepted. Why? Because the range of this function is greater than or equal to 3 over 2. So that is why this decision was made. All good, all clear. The main thing is understanding that k is replaced by 4. Otherwise, you have to do a lot of working and determine the nature. Now plug in f double prime x. So now plug in x is equals to 2/3 in f double prime x. So f double prime of 2/3, that is 72. And this is 3x minus 4, 3 into 2/3 minus 4, the whole thing cube. Now focus on this. This 3 and 3 will cancel. 2 minus 4 is negative 2. Negative 2 cube is negative. So denominator is negative. Numerator is positive. Therefore, f double prime of 2/3 is negative. Therefore, it's a maximum. And how do we find the y coordinate? To find y coordinate of stationary point, evaluate f of 2/3. What is f of x? F of x is 4, 3x minus 4 raised to power of negative 1. That is 4, 3x minus 4 raised to power of negative 1. I've taken it down, plus 3x, plus 3 into something. So let me plug in 2/3 over here. Let me plug in 2/3 over here. Do the cancellation. 3, 3 cancels out. 3, 3 cancels out. 2 minus 4 is negative 2. 4 over negative 2 is negative 2. And this is 2. This comes out to be 0. Therefore, the coordinate is what? That is 2/3 comma 0. And what is the nature? Maximum. So this is the value of A. That's the x coordinate of turning point. And it's a minimum. So now x is, no, we are not plugging in 2/3. We are plugging in 2. We should be plugging in 2. My bad. So I plugged in the wrong value. So let me just erase this thing over here. And I think that was a mistake that I made, because the value that needs to be rejected by mistake, it was plugged in. So let me just clear this thing out. Okay, so now f double prime x, x is equals to 2 in f double prime x. So f double prime x is what? That is negative 12 over 3x minus 4. Negative 12 over 3x minus 4 whole square plus 3. This plus 3 is becoming 0. This is 72, my bad. 72 over 3x minus 4 whole cube. So this is 72 over 3x minus 4 whole cube. Now plugged into f double prime of 2, that is 72, 3 into 2, 6. 6 minus 4 is 2, 2 cube is 8. This is positive. Therefore, this is a minimum. And when x is 2, let's evaluate f of 2. What is f of 2? F of 2 is 4, 3x minus 4. 4 over 3x minus 4 plus 3x. So let me plug in 2 over here. Let me plug in 2 over here. 3 into 2 is 6. 6 minus 4 is 2. 4 over 2. 4 over 2 is 2. 2 plus 6 is 8. F of 2 is 8, if I'm not mistaken. So are they asking us? No, they're not asking us the y coordinate. So the coordinate is 2, 8. The value of a is 2 because that is the stationary value of x. And what is the nature? The nature is a minimum. So that's the kind of question that is from one of the recent past papers. I think it's 2022. And this is the basic concept of stationary points that we need to study. Till the very next class, take care, everyone.